Okay, so there's some homework questions. Board's being a little frozen, but just a few announcements. Don't forget by Friday, turn in that signed syllabus, the signed student release form that I gave you yesterday, and then the information sheet that was emailed to you. I've looked at some of the responses, but not all of the responses. How many of you did not or do not have a Chromebook or a laptop right now? Everybody has a Chromebook or a laptop that they can use for homework? Fantastic. Okay, here we go. Today's lesson is all about function types, and there are three main types that we're going to talk about. I'm going to make this bigger so that way I have plenty of room to write in it. Our three main types that we're going to look at are linear, exponential, and quadratic. So we're going to fill out this chart that I gave you on that handout. No, that was just quadratics. Yeah, I did put it on a yellow sheet last year, but it was only quadratics. Similar kind of chart. All right, so let's talk about linear. When I say linear, what do you think of first? A line. That would go under the word graph. So over here at graph, draw you an XY axis and then put a line on it. So your line can be vertical, it can be horizontal, or it can be slanted any kind of way. So if you were to look at a graph, straight lines are linear. What about a function or an equation? They usually start out as like y equals mx plus b. That's usually what everybody talks about. Does anybody know what form this is in or what that tells you? It's slope-intercept form. That's exactly right. What letter is our slope? M. And you guys probably know some equations for slope. There might be three little words. Rise over run. There's also one more equation that you use for slope probably back in Math 1. Y2 minus over. Good. And you use that when you had coordinate points. You were given 2 points and you found the slope between them. We're actually going to use that equation when we do Unit 2 in a couple of weeks. And so we'll do some writing equations of a line given 2 points. But for right now, the most you need to know is like the y equals mx plus b. What is the b? The y-intercept. The b is the y-intercept. And so that's why we call it the slope-intercept form, because it tells us those two things. It tells us the slope and it tells us the y-intercept. There's another form that we're going to look at later, so if you have a little bit more room in that box, then you can add to it in a minute. All right, tables. I'm going to give you a little description of the tables, of what the tables look like, because that will help us with something else that we do later on. So for a table, if you're given an XY table, we would say as X increases, at a constant rate, Y will increase or decrease by addition or subtraction. As x increases at a constant rate, y will increase or decrease by addition or subtraction. When we do examples of tables, that will make the most sense, but you will be looking basically for patterns. What's the pattern in the y values? If you add the same number each time or subtract the same number each time, it will be linear. All right, the next function that we have is exponential. Do you guys know anything about exponential functions? They go up and they go down. You've probably heard those words before, exponential growth and decay, right? Probably in science classes. So let's start with a graph of those. So I'm going to graph both of them. So exponential growth starts off, kind of levels off, but then goes up really quickly. And decay decreases really quickly, but then levels off. So there's examples of both of those, exponential growth, exponential decay. The key thing is that they level off at some point. What's the root word of exponential? Exponent, right? The key thing with an equation or a function is y equals ab to the x. The x is an exponent. That is key. So for exponential, anytime x is an exponent, it is exponential, no matter what else is in the equation. If x is in an exponent position, it is exponential. Now, we're going to learn all about exponential equations when we hit Unit 3 in this class, but to give a little bit more detail in case that you look at this later, your A value is your starting value, and the B tells us if we have a growth or decay. So A is your starting value, B tells us growth or decay. For tables, it's very similar to linear. As x increases at a constant rate, y will increase or decrease by different operations. What do you think are the two different operations? Multiplication or division. Yep, so write this same thing, just change those last two words. As x increases by a constant rate, y increases or decreases by multiplication or division. So when you look at a table, the y values, if you're multiplying by 2 each time or dividing by 5 each time, that's a great example of exponential. Last on our list is quadratic. What can you tell me about a quadratic? Now, don't do the quadratic formula. So, not opposite of b, that's how we solve. So, we'll get to that in Unit 5 this semester. But maybe start off with y equals. We can start with the equation first. So, y equals ax Got to put a squared on that. So ax squared plus bx plus c. Good. That is our standard form of a quadratic. Standard form. We also had some other forms, didn't we? Does anybody remember the other one? Think about that parabola selfie that we did. Vertex form. Good. Does anybody remember what that is? It's got a parenthesis in it. Ax minus h squared plus k. Almost had it. That was our vertex form. And then we also had our factored form. We did a lot of stuff last year, didn't we? So we have our standard form, our vertex form, our factored form. The key thing is in 2 out of those 3 equations, what's in them? The squared, yep, the squared. They do have parentheses in 2 of them. 2 of them also have a squared. I could go with either one with that. Lots of parentheses, but lots of squared in there. So the key thing with a quadratic, the highest power is x squared. So you might want to add that down as a little note. Highest power. My board does not like me today. Highest power is x squared. If it's x to the 3rd power, it's not quadratic anymore. We call it what? X to the 3rd? Cubic. Yeah. It's all coming back. All right, I'm going to skip the tables for a second. Let's go to the graphs. There are 2 types of graphs that you will see if it's quadratic, very similar to each other. Whoop. What do the 2 graphs look like? Whoop, okay. Whoop and a whoop. Yep. Also known as parabolas that open up and open down. But a whoop and a whoop sounds good to me too. Sometimes we say it looks like a smile and it looks like a frown. All right, now we're going to talk about what the tables look like. Now I'm going to be honest with you. I didn't know this little trick with quadratic tables until I was about 5 years into teaching and they changed the curriculum and they added this back in. So I went all through high school, through 4 years of college, 1.5 years of grad school, 5 years of teaching, and then somebody says, you can check the second difference. And I was like, what are you talking about? So we're going to see examples of it. It's really quick and easy because what does difference mean? You subtract. So the second difference means you subtract twice. So for quadratics, we want to check the second difference is constant. All this rain, I think, is making my board slow. So check to see if that second difference is constant. And remember, difference just means subtract. So you'll notice on this back side of this worksheet is the exact same table for you. So I thought for some of you on the back, you can put your examples, and then that way you can have those. If you don't want to put examples on the back, you can put them on a separate sheet of paper. There are a few times where you might need that second sheet of paper anyway, just to work out some problems. But I think with the next ones, we can identify them first, and then you can put them in your table as examples. So I'm going to go kind of in order. We're going to start with equations first. I'm going to give you 4 equations, and I want you guys to tell me what type they are, and then you guys can write them down if my board decides to change. Yeah, wish we had some magic words there. Well, y'all have a good first day yesterday? I think tomorrow's going to be really rough, like getting out of bed and stuff. Like first day, you're kind of excited. Second day's a little slow. Third day's rough. And the rest of the county is going back tomorrow, so expect delays. So don't forget, you might hit a little bit more traffic tomorrow. So right now we only have about 150 kids going to school, and tomorrow we will have a lot more than that. Yes, you may. Come on up. Here, I'll bring it to you. It's wireless. It can go anywhere. Okay. Hold on. Let go. Yep. Oh, that red bag back there is candy that I found at my house that y'all are more than happy to take. Yes. No. Well, I watched part of one with my aunt because she likes the show, but I have not watched all of it. Do what? Oh, I don't know. I haven't even watched enough to decide. It was seriously like 15 minutes. So I will start watching it though, and I will let you know. Here we go. Okay, let's talk about them real quick, and then you can write them down as examples. What about this first one? What kind of problem is that? Exponential. Why is it exponential? It's got, not the squared, but it's got x as an exponent. Good. Example 2, what do you think that one is? That is correct. That's a nice standard form quadratic for us. What about C? Linear. That's right. Even though the y is on the wrong side, it still looks like mx plus b. And our last one down here, exponential, because the x is in the exponent. Doesn't matter what's with it. Put it in the right spot on the back of the folder or back of the handout, or just write it in your notebook as examples. And you can just write LEQ beside these. This is what you're doing on your homework. I'm going to give you an equation. I'm going to give you a table. I'm going to give you a graph, and give you some in a few different forms. And you are just going to click on it and then decide if it's linear, exponential, quadratic, or neither. There might be some that we see in a little bit that don't fit either one of those 3 categories, because there are lots of other types of equations and functions that we have in math. But these are the main 3 that we are going to focus on, definitely for the first quarter that we have. So linear, exponential, quadratic, or neither. Now, these 4 examples right here, everything was already pretty much solved for y. They started with y equals, right? Do you think every problem that you're going to see is going to be in that y equals format? No. So what should we do? We should solve it for y. So that's going to be key on the next few examples that we need to do. So I would definitely write the next few on a piece of notebook paper just to see what they are, and then we're solving for y, and then you can put them in the right category that we have. Also, if you're not sure what they should fall in, you could always go to your calculator and go to y equals and type it in, like that one that said y equals on the other side. you could just type it in y equals and hit graph, and then you could kind of see what it looks like. You could also type it into Desmos and really expand that graph to kind of check to see what form it would be in. That would be a great way to kind of look at those graphs. For those of you watching the video, just go forwards until the slide changes. I'll just tell a story. Did y'all do anything fun this summer? What? Broke your thumb? How'd you do that? Oh, well, that's not fun, but you went to Disney World? That's right, you left like right as school ended. Yeah, that's fine. My kids haven't been yet. I've been twice, but once I was like 3, so I remembered nothing. I remember the pool at the hotel and the ice cream truck driving along the beach. Then I do Disney World. I remember getting lost at the parade because my brother was supposed to be holding my hand, and we were going towards the front to see, and he let go of my hand. And I was like, my tool, my tool, my tool. That's how I spoke when I was like 3. And then he came and grabbed my hand and was like, come on. Nice brotherly love. Yeah. But then I went when I was a junior in high school, and that was really fun. We had a band competition. Oh, that stinks. Yeah, I bet so. When I was a junior, I rode Space Mountain, and it broke down, and the lights came on in the middle of it, and I was like riding it, and I was like, is this supposed to happen? And my friend beside me goes, no. Oh. Yeah. Oh. Well, that's okay. Seriously, computer, I hate you today. It's all right. I know. What's some magic words, you guys? Got any? Did not work. Yes. Doing the... we're actually going to have next Thursday is officers, so you come next Thursday. And then the next Thursday is full group. Yeah, if y'all want to join Interact Club, we meet Thursdays at lunch every other Thursday, just twice a month. We're a service group. We have painted murals. We have picked up trash. We have sung Christmas carols. There we go, write down number 1. But we do all kinds of fun things in the Interact Club if you would like to join us and do some service and good for the community. All right, like I said before, these problems are not solved for y. Just write them down one at a time. That way you got room to work them out. But if it is like this one, we need to get y by itself. What would you do first to get y by itself? Good. Think about your order of operations. You got to add or subtract first when you're solving because you want to go in reverse order. Now, with me, I like to put my variables before my whole numbers. So on that right side, I'm going to write negative x plus 7. I subtracted the x, so it's negative, and the 7 stays as a positive. But if you reverse it, that's fine. Just keep the same sign that's in front of the number or variable. All right, what's my last step? Divide everything by negative 2. So remember, when you divide, you have to divide every single part. So y equals negative x divided by negative 2 is 1/2 x. Good. The negatives cancel out, and just like last night's homework, x over 2 makes 1/2 x. And then 7 divided by negative 2 is negative 3.5, or you can leave it as the fraction, 7 over 2. Now that it's solved for y, we can definitely identify this. This would be a linear function. That's right. It looks like y equals mx plus b. And if you want to go back to your chart, I would go back to another slide, but it may take 10 years to get back to this one. You can add this type of form under the front part where we did all the information. This is actually a standard form linear equation. And in standard form, it is AX plus BY equals C. So you can add that on the front under linear. AX plus BY equals C. That is the standard form of a linear equation. And in Math 1, some of you may have talked about that, but some of you may have skipped it because a lot of times we just said solve it for y, put it in slope-intercept form because that's easier to graph. All right, problem 2. XY equals 8. Write that down. What would you do to get y by itself? Divide the x. Now, when you divide by x, that means x is in our denominator, right? We're dividing by x, so x has to stay there. Have we done anything where x is in our denominator? No. Let's go to our calculator and let's make a graph of this. So everybody go to y equals real quick. And let's type in 8 divided by x in y equals. And then hit graph. Does that look like anything we've graphed before? Nope. Math 2, this is a unit that we didn't get to because all of them snow days. It's actually called an inverse function. Or when we do it later on in Unit 9, it's going to be a rational function. But it's graphed like this. Is that one of the 3 that we talked about? Does that look quadratic, exponential, or linear? Nope. So this one is neither. If x is in the denominator, say neither. Zoom 6. There you go. You're welcome. All right, write down problem number 3. Do you need to do any work to this one? Do you know what it is? What is it? It's quadratic. What form of a quadratic is this? Vertex form. Even if you forgot its vertex form, it's got a squared. Anything that has that squared there, where x will eventually be getting squared, is a quadratic. All right, question 4. Yep. Yeah, so in number 2, we know it's neither because x is in the denominator, and we make that graph. It's got 2 curves on the same xy axis. 2 curves is nothing. We don't know what that is yet. We haven't learned that yet, so it's neither. Now, if you look at the one before it, like right here, if you just look at that fraction, where is x there? At the top. If x is in the top, you can say linear. But if x is in the denominator, neither. You're welcome. All right, in question 4, it's almost solved for y, but it's got some parentheses, so we need to do some work. What should we do? Let's distribute and then add the 6 over to get it solved for y. So y minus 6 equals 2x plus 8. Let's add 6 to both sides, get it in y equals format. We end up with y equals 2x plus 14, which is a linear problem. Depending on what you did in Math 1, you may have heard point-slope form. This one is actually in point-slope form, but I don't know if y'all talked about that or not, so if you didn't, just solve it for y. Get y by itself. That looks like mx plus b. It must be linear. Number 5 is already y equals, and some of you are already writing it down and probably already know what it is. What is it? How do you know it's exponential? Good. X is an exponent, so this is exponential. No work to do on that one. Just look at where x is. No matter what is with x, if x is an exponent, it's exponential. It can have multiple things to it. Now, our last one, you guys know already just by looking at what we wrote down at the beginning. What form is that one? It is quadratic because it's in that factored form of a quadratic. But if you forgot, you can put your little arrows. Do you remember how we have to FOIL or distribute? Everything in the first has to multiply everything in the second. So what is x times x? X squared, which means it's automatically quadratic. Then x times 3. Then we distribute that -2. And then combine like terms. You don't have to distribute it out though. I just wanted to do it as a little review. We're going to do more of that in Unit 4. X is an exponent. Anytime x is an exponent, it's exponential. Sometimes the hardest part is dealing with these equations, especially when solving them. So we kind of got that out of the way. And so the next ones that we're going to look at are going to be the graphs. And to me, the graphs are the easiest. So if they give you a graph, it has to follow one of the 3. So what does it look like to be linear? It's got to look like a line, right? Horizontal, vertical, slanted. Either way, it's a line. What does it look like to be quadratic? Looks like a U, upside down or right way, either way works. And last, what does it look like to be exponential? It's got a curve, right? And the curve has to level out one way or the other. If it doesn't look like one of those 3, you say neither. So there's other shapes that it could take, like it could go up kind of like linear, but then curve in the middle, and that would not be anything. You don't have to write these down. Let's just do them together. What do you think about A? Quadratic. Let's go down below. C. Linear. Back up here. Exponential. Even though there's not a curve through it, it still follows that pattern. And what about this one? Neither. This is actually one that we're going to graph next week. This is an absolute value graph that makes a V. And so we'll start graphing those next week. So you'll hear about those a little later. All right, now we're going to look at some tables. Look how fast this is going now. Copy this table down, probably on your notebook paper. You can add it to your chart later, though, once we know which one it falls in. So just real quick. While the board's going fast, you copy fast. So when you get your homework tonight, some people see different kind of graphs and they're like, I'm not sure which one it falls under. If you're not sure, pick neither, because that's probably what it is. So it's got to look exactly like the ones that we put on our paper to be one of those 3. Now, looking at your chart, how do we know if something is linear if it's a table? What were those last 2 words? Addition and subtraction. How do we know it's exponential? Multiplication, division, and quadratic, second difference. Okay, so it's got to follow one of those 3. So first off, the x's have to be consistent, but if you notice in this one, it goes -2, -1, 0, 1, 2. We're going up by 1 each time. So now let's just look at the y values. What's happening from here to here? You're adding 3. What's happening from here to here? You're adding 3. Here to here. And last, add 3 again. So each time we're adding 3, so that would be linear. All right, here's your next chart. Copy this one down. Linear ones I think are pretty easy. You add or subtract to get from one y value to the other. If it's the same number every time, linear. Now you want to think about doing the same thing, and I usually check for linear first. Do I add the same number to get from one to the next? No. You can check that real quick. Here would be 0, here would be 2, here is 4, here's 6. Doesn't work. Okay, do I multiply or divide to get from the same number to the same number? Well, -6 times 1 makes -6. If I times it by 1 again, that doesn't work. And 0 times any number should be 0, so exponential is not going to work here either, right? So now we check quadratic. So quadratic said the second difference. So with that, I just do how many numbers are between. So how many numbers are between -6 to -6? 0. How many numbers are between -6 to -4? 2. How many numbers are between -4 to 0? And how many numbers are between 0 to 6? 6. This is called your first difference. Okay? Do it again. So how many numbers are between 0 and 2? 2 and 4? And 4 and 6? 2. These are your second difference. Are all of those the same? Yeah, so it's quadratic. So that's how you do second difference. Find out how many numbers are between. If the second time you do it is all the same number, it's quadratic. Does that make sense? Okay. Our next example that will show up in just a minute has some titles at the top. And so instead of saying X and Y, it puts titles on there. You can just call it X and Y for your notes that you have. But a lot of times when we see tables, they're in word problems. And this next table is about sending emails. But you guys can think about it as maybe sending text messages or sharing your Snapchats. I really don't know how Snapchat works because I don't have it because I'm just old. I just do Facebook. But anyway, you could think about it that way. So what happens if there is a really funny, like, text message or Snapchat thing? You're going to share it with your friends, right? And what are your friends going to do? They're going to share it, and they're going to share it, and they're going to share it. So that's kind of what this email forwarding, you can think about sharing your Snapchats or whatever you call them, reposting, clicking. I don't know. Copy down the table. Again, you can call this X and Y instead of using the titles. With tables, you want to look for the pattern. No matter what the labels say, you want to think about the pattern. What's going on with your Y values? But you also want to just double check and make sure those X values are consistent. So what's happening with our Y values here? You're multiplying by what? By 7. 8 times 7 is 56. Grab those calculators and double check it because I don't know many people who can do 56 times 7 in their head, but some people can. What's 56 times 7? 392. What's 392 times 7? You are correct. So this one does work out, but you may see some examples that it doesn't. It might be like times 7 times 7 times 6. So can you multiply by a different number? No. What happens when you multiply by the same number? Exponential. So remember, if you multiply or divide by the same number, it is exponential. So if you share that email, each person shares the email or Snap or whatever with 7 friends, it's going to increase very quickly. We got one more table we're going to look at, and it deals with some oven temperature. Now, a lot of times you can get ideas about what the table will represent based on the information. So what happens to the temperature in an oven? It's going to increase when you cut it on, or it's going to decrease when you cut it off. So if you think about something that increases and then decreases, that could be quadratic, right? But what if you're only looking at a specific time period? What if you only look at when you cut the oven on? Well, it is going to keep increasing, though, forever. No, so maybe not exponential, but maybe part of it could be that way, only if you look at a certain time. Could it also be linear? Yeah, so oven temp actually could be a lot of different things, right? So we need to look at the data to figure out which one it is. And maybe if my board changes, we can do that. But when the next one comes up, copy it down and then see which one you think it will be and why it would be that. I really apologize for the slowness of the pace. Again, if you are watching from home, feel free to fast forward at this time until you notice that the information on the board changes. We hope you enjoy your day here at the early college of messed up board times. If I knew all the words. Singing some songs in Spanish if I know them. My Spanish teacher used to make us like memorize songs and sing them to her or say them to her before or after school to test our pronunciation of words. She was the only Spanish teacher. So we had De Colores, La Cucaracha, La Bamba. There was something about, I think his name was, I don't remember his name, but he had to wash his face. And so we talked about all the like body parts because he had to wash his face and wash his hair and stuff. And then there was the one about the months of the year. Uno de enero, dos de febrero, tres de marzo, cuatro de abril, cinco de mayo, seis de julio, siete de... No, I said it wrong. Anyway, yeah, thanks. Yeah, she said that we were really just cussing at her when we said gracias. Because she said... There we go. There's the one. Okay, copy down that table real quick. Again, you don't have to say time and temperature. You can say X and Y. What's going on with our oven temperature? It's going down. It's going down linearly because it's going down by how much? 50 each time. So we're just put a little L here for linear. And then you can copy down this right here. What is this? I don't know. Is it? They are coordinates. That is correct. These are all XY coordinates. So sometimes we're given information as coordinates, but we could take those coordinates and put them into a graph or a table. There we go. So if you want to write them down like this, you can. I prefer to see them as a table because I get confused from seeing all those numbers together. So remember, your first number is your X value, which are nice and consistent, and your second value is the Y. I know I've had people before when I handed this out like on a worksheet, they went through and highlighted all of the Y values, which you could definitely do that if you see this like on a test or quiz. You could say, okay, these are my Y values. What's going on with them? But don't forget to check your X values to make sure that your X values are consistent. 1, 2, 3, 4, 5. Those are what's happening with the Y values. Now, I like to go in order, and I like to check linear, exponential, quadratic. So, linear. Are we increasing, because these are definitely going up, are we increasing by the same amount each time? No. So, next, do we multiply to go up by the same amount each time? Nope. So, third, we check that second difference. So, let's see if it's quadratic. So with quadratic, how many numbers are between? 9. How many numbers are between? If these numbers were all the same, it'd be linear. Now we check it again, the second difference. How many numbers are between? Between. And between. So it must be quadratic. There's one last thing that we have to do. I'm not going to turn the page because who knows how long it will take. So I'm just going to do it on this page. And we have seen our information here in lots of different ways. We have seen, I should have clicked that off so y'all can see all that. We've seen information given to us in tables, in graphs, and in coordinates. There's one other way that we haven't done, and that is as word problems, right? Because in math, we have a ton of word problems. You can add this on your chart that you have. You can just put an example in one of the boxes. You can put it under the word linear in that very first column if you want to. Now, the example that we had for linear is one that we just did about the oven. Explain that in words. What happened to our oven? Perfect. That's a great example of linear. The oven temperature decreased by 50 degrees every 10 minutes. If I think about that, I can make a table of it, right? And in that table, every 10 minutes, we're minusing 50. And that's what happens in this problem. We're minusing to get to the next number. All right, let's do exponential. Hey, Alex, don't forget to write this down. All right, in exponential, also think about a table or think about things that maybe have exponential growth or exponential decay. You talked about that a lot in science class, right? What's something that happens that could model exponential growth or exponential decay? Population. The population doubles every year. What does that mean? Not 6. There you go. 1, 2, 4, 8, 16. Because what are you doing each time? Multiplying by 2. Another example of that is when you increase by a percentage. So besides saying doubling each year, you could say the bacteria decreased by 2%. Whoops, not J. 2% every hour. I don't know. I'm getting in the middle of that one there, so I'll move this up. But anything with exponential that talks about how the graph doubles, like multiplying or divides or by percentage, that's going to mean exponential. All right, so the last one we have is quadratic. Now, quadratic, I think of the graph as a quadratic. Think about that curve. What are some things that make that parabola shape? More importantly, probably the one that goes up and goes back down. Huh? Roller coasters. Yep, that would be a good one. What's something else? What? Okay, yep, besides tracks and roller coasters. Good. A ball was thrown from the outfield to home plate. That would follow that curve, right? Remember all those examples you did in Math 1 and Math 2? You throw the rock off the cliff, it hits the water. You throw the rock off the top of a building, it hits the ground. Anything that makes that curve. So what I would think about with linear and exponential, think about numbers. What am I doing with the numbers? Could I make this into a table? Am I multiplying or dividing, exponential, or am I adding, subtracting, linear? With quadratic, think about the shape. All right, last thing I want to tell you is your homework. When you go into Canvas, you are going to go to today, 8/12, and you're going to click this link. Log in with your school Gmail account. You're going to do something called Wiser Me, which is an online worksheet. And when you go in, you just scroll down, and then you click on each one. You're going to click on this one, and you're going to tell it where it needs to go, okay? And then down here at the bottom, it's listed in the categories. If you accidentally put one in the wrong spot, you click it, it sends it back to the top. So just click the one that you have, put it in the category, and then when you get done, you can hand it in. If you're not quite done, click Save, and it'll save your progress. I know you guys don't have a whole lot of time, but you got about 15 minutes or so. You might be able to get most of this done. Some of you may get all of it done. All right, but log in to Canvas, click that link, sign in, click where they need to go. Let me know if you got any questions.